All right. Good morning, good afternoon, good evening, ladies and gentlemen. Welcome to another set of tutorials with me, Aubrey. And in this lesson, we look at some concepts in from the ECZ mathematics past papers. So this lesson is good for those in I'm sure it should be October or December, somewhere there. So let's dive into the lesson. So the question is asking us to calculate the volume of the frustrum of the following. So we have part A and part B. So I want you to pay attention to how I will be working out part A so that you'll be able to work out part B by yourself. So this is very important. I'm just going to do part A and you do part B. So first of all, let's explore what a frustrum is. Okay, so when you have a shape like that, okay, then you decide to cut this shape at any point. Okay, when you decide to do that, that will remain shape at the bottom that that doesn't look like the original shape. So the shape that is left that doesn't look like the original shape is what we are calling a frustrum of this original shape. Okay, and ideally, to get the volume of the frustrum here, we just find the volume of the original shape. Okay, and then we are going to subtract the volume of the shape that was on top. And as you can see, when we subtract this volume of that, we're going to remain with a frustrum. So let me repeat this. To get the volume of a frustrum, you find the volume of the original shape. Then from the original shape, you just find the volume of the top part that was cut. Okay, and as you can see, when you subtract from that, you're going to remain with the volume of the frustrum. So this applies to all types of frustrum. So if you are dealing with maybe say when you did anywhere at the point, there'll be the top part and the bottom part. The bottom part is what we're calling a frustrum, and to find the volume of the frustrum, we just find the volume of the entire pyramid, the original pyramid. From it we subtract the, and when we do that, a frustrum, as you can see here. So this is the approach that we're going to be doing in our questions. So I'll do question A, you do question B. Let's dive into them. All right, so for question A and for all the other questions, first of all, we tried to estimate how the shape might have looked like. So this was from a cone. A cone looks like this. Okay, it means it would have maintained the other end of the cone, that is to the other part of the cone, that is 6 centimeters, and we have the height there. So what we should know is that this cone had some sort of a height, which we're going, this cone has a height which we're going to call h, and this cone was cut, and we had that length which was formed, which is 25. From this point of the cone, from this end to that end is 10 centimeters, 20 centimeters, but what we're interested in is the radius, not the diameter. So the radius, which is from this point to that, is half of the diameter, so which in this case is 10 centimeters. That is, let me just do this. That is from the center there to that point there. So this is where the green line is. So from this point to that point will be 10 centimeters. Then from this point to that point to the middle there, it is 6 centimeters. All right, so what we know is that the volume of the entire cone, okay, is equal to the volume of the top part of the cone plus the volume of the bottom part. So this is the equation we are going to use. What we just need to do is find the volume of the entire cone. Then we also need to find the volume of the top part, which is this part. Then we make volume of the bottom part the subject of the formula, and what we'll get will be our answer. All right, so now the volume of we need to find the value of h. How are we going to find the value of h? We also don't know the value of this height here. Okay, we don't know the value of that height. Let me just show with my hand. We don't know the value of that height, which we're going to call x. Okay, we don't know the value of that height, which we're going to call x. We also don't know the value of the entire cone, the height of the entire cone. We don't know yet. So, but we can use ratios and proportions to find the values of both x and h there. Okay, so what we know is that this h height will be equal to this x plus the 25 that we have there. So let's write out that equation. We know that h will be equal to x plus 25. So that's the first thing that we have there. So now we know that, which is x plus 25, we can say x plus 25 has a direct relationship to the diameter at the bottom here. Okay, or let me say the radius at the bottom here, which is 10. Okay, and this x has a relationship with the diameter here and not the diameter at the bottom. So x now has a direct relationship with the 6 there. So what we just need to do here is we cross multiply. So 6 times this and x times that. So we're going to get, so we say x times that will be 10x, say equal to 6 times everything there. So 6 times x, that will be 6x. 6x, just move there, 6x, then we say, so that will give us 150. So we group the like terms, so this would be 10x. When the 6 comes this side, it will be negative 6x equals to 150. So now what is 10 minus 6? So that will be 4x, which is equals to 150. So we divide throughout by 4, which is 150. 150 divide by 4, which is x is equals to 37.5. Also find our h, so we just replace in this formula right here to find the height in this formula. So we're going to say height, we know that height is equals to x plus 25, meaning that our height will be equals to x, which is 37.5 plus 25, meaning that our height is equal to 62.5. 62.5. So now from here we have everything that we need to solve this question. We have everything that we need to solve this question. That we need. So our height, which is 62.5, we will draw the diagrams. So the height of this entire thing is 62.5, and it has a radius at the bottom, which is 10 centimeters. All right, so this is the first shape, which is the entire object. Then for the top part of the object, our height, which is x, you see from the bottom to that, which is x, is 37.5, and it is spanned by a radius. It is spanned by a radius 6 centimeters. So we have everything that we need. We just need to find the volume of this shape. From it, we subtract the volume of the top part, then we are done. We find the volume of the entire shape. All right, so what is the volume of a cone? So to find the volume of a cone, so for this first one, volume of A of this one, which is pi r, which is the base A, which is pi r squared times the height. So the volume of this one will be pi, which will use 3.142 times the radius. Remember, radius is from the center to that, so which is 10 squared times the height. Oh, let me see times. Let me just move this over here. All right, times the height. What is our height? Our height 5. So now punching that in your calculator, let's see, let me punch. So punching that in your calculator gives you 1963.5. So pi, remember we used 3.142, radius, which is from the center to that point, which is 10, and the height of the original shape, which is 62.5. We punch that, we get that volume. So that is our volume of the shape. Then the volume of the top part, which we're calling volume B or volume A, will be equals to, again, this is the same shape, so it is pi r squared h, and in this case pi, we again use 3.142 times the height, the radius. It's from the center to that point, so which is 6 squared times the height, which is 37.5. So punching that in your calculator, so you're going to get that length, the volume there. So you're going to get that volume. So now remember, to find the volume of the frustrum is just the bottom part. So we just get the volume of this entire shape, we subtract from it the volume of the part that was cut, then we remain with the volume of the bottom part. So we're saying volume of the frustrum, will be equal to this volume right here, which is 19637.5 minus this volume right here, the volume in blue. So the volume right here, so let me just drag that. Minus the volume here in blue, which is 4241.7. So now subtracting that, you get, so punching that in your calculator, you get 15395.8 centimeters, because we are measuring in centimeters. Then you see everything is in centimeters, so we just say centimeters, then volume is cubed. So that is how you're going to calculate the volume of a frustrum. So let me run you through the steps that we followed. Okay, so the first step is we were given a frustrum. Okay, we were given a frustrum. We needed to imagine how it would have looked like. Okay, after imagining how the frustrum would have looked like, we said this is the bottom part where it was cut from. We need to find the original height. Okay, then we also know that we don't know the height of the part that was cut off from the frustrum. Okay, and really, you know, the total volume is equals to the volume of the top part minus volume of the bottom part, of which when we make the bottom part the subject of a formula, which is volume of B, would be equal to the volume of the original or the original volume minus volume of the top part that was shaped. So this was our guideline. We needed to find the volume of the original shape. Then from it we needed to subtract the volume of the part that was cut off from. So here we have we find the volume of the original shape. We just needed to find the height and this x, and that is all. We use ratio and proportions. This height goes with the bottom part, then this x goes with the part the middle part there, which is 6. Then we just do some ratio and proportion calculations. Then we found the heights of each, and we use the formulas to calculate the volume. So next question,